Section 4.6, we're going to look at multiplying and dividing complex numbers. Before we get into a couple problems, I do just want to talk to you about the properties that we see here. Alright, so I'd just like you to copy this down. And we're going to actually go into this a little bit more in detail in class, and we'll prove why each of them is true. Alright, but for right now, just know that I equals the square root of -1, and that I squared equals -1. I cubed equals -I, or the opposite of I, and I to the fourth power is equal to simply the number 1. So as I said, write these down, and in class we'll prove each of them true. So you'll have them in your notes. What I do want you to know, though, is that this piece right here, I squared equals -1, that's the most important part for this section. Alright, this is the most important for this section. And you're going to need to know that as we start multiplying and dividing complex numbers. Just remember, I squared equals -1. Okay, let's take a look at this first problem that I have down here. We have -8 minus 3i times the quantity 2 plus 4i. Looks like we have two binomials. Remember, as I said in the previous part to this section, we can think of I as we can use it the same way we would have a variable. Right? So you can think of I as a variable. Right? So if this was -8 minus 3x times the quantity 2 plus 4x, many of you would automatically jump and say, oh, Mr. C, we should FOIL. And you're right, that's what we should do. So with the I as well. So we want to FOIL. So we're going to do first, outside, inside, last. So first is -8 times 2 is going to give us -16. Outside, -8 times 4i is going to give us -32i. -3i times 2, that's our inside, that gives us -6i. And -3i times 4i gives us -12i squared. So we want to look at our like terms. So we've got two terms here with an I, so we want to combine those. So I've got -16 and -32i minus 6i gives me -38i. And here we've got -12i squared. And I'll put this in a different color. Remember, I squared, what does I squared equal? I squared equals -1. And that's what we have up here. So this is just like -12 times -1. So I've got -16 minus 38i. -12 times -1 is +12. And now I'm going to go ahead and combine my like terms of -16 and 12. So -16 plus 12 gives me -4 minus 38i. And that would be our final answer. And this is how we want to write it in standard form. Remember, standard form of a complex number is a plus bi. Alright, so we don't necessarily want to write it -38i minus 4. You want to make sure the term with the I is last. So that's multiplying complex numbers. Let's take a look at division. Come down here, we've got 5 minus 2i divided by 3 plus 8i. And remember, I is essentially saying we're taking the square root of a negative number. So I'm going to focus real quick on this 8i right here. I'm going to come on over here and say 8i. What does that mean? Remember, I is basically a negative under the square root. So we have the square root of -8, which is the same thing as 8i. And in the previous section in 4.5, we learned how to rationalize the denominator. right? We learned how to get the square root out of the denominator and into the numerator. And we did that by multiplying by the conjugate. That was one of the ways. And since having an I in the denominator is basically the same thing as taking the square root of a negative number, that means you have the square root in the denominator, we are still going to want to multiply by the conjugate. So, what is the conjugate of 3 plus 8i? It's, remember, taking the conjugate, you just switch addition to subtraction or subtraction to addition. So the conjugate is 3 minus 8i. And I'm going to put that in the numerator as well, because whenever you divide something by itself, this number is 1. So when we multiply by 1, we don't change the value of this number here. All right? It's just going to change the way it looks. So we are going to start foiling. Well, we're going to want to FOIL the numerator and the denominator here. So I'll start with the numerator. All right, so we've got 5 first times 3, so 5 times 3 gives me 15. Outside, 5 times negative 8i gives me negative 40i. Negative 2i times 3 gives me negative 6i. And negative 2i times negative 8i gives me positive 16i squared. And that all came from foiling the numerator. I'm going to go ahead and FOIL the denominator. And I've got 3 times 3, which is 9. 3 times negative 8i gives me negative 24i. Positive 8i times 3 is positive 24i. And then lastly, 8i times negative 8i is negative 64i squared. So let's simplify the numerators and the numerator and denominator independently. Each of them have like terms, so we're going to want to combine those. So we've got 15, we've got negative 40i minus 6i gives us negative 46i plus 16 times, and remember, we have this I squared, which is negative 1. So I've got 16 times negative 1. Here I have 9, negative 24i, and positive 24i. Those are going to cancel. And I'm going to get minus 64 times negative 1, because I squared is the same thing as negative 1. So we're going to continue simplifying. So I've got 15 minus 46i. 16 times negative 1 is negative 16. Over 9 plus 64, because negative 64 times negative 1 is positive 64. And the last thing I'm going to do is simplify the numerator here. Did I say 9? We've got 15 minus 16, which gives us negative 1, minus 46i, over 9 plus 64 is going to give us 73. So I'm fine with you keeping your answer this way. If you would like to write your answer with 2 fractions, you can do that as well. Just make sure the denominators are the same, and you're going to have negative 1 above 73 here. We have minus, so minus goes in the middle, and then 46i goes here. So either of these is acceptable. They mean the exact same thing. Alright, it's just one is expanded. I believe your book is going to give you your answer in this form, but if you want to leave it in this form, I'm okay with that. Alright, and that's the end of part 4.